Welcome back, THS Chem. Today we're talking about kinetics, and we're going to get our kinetics notes down in our notebook, so take it out. Alright, let's get going. Alright, first of all, what is kinetics? It is the study of the rates of chemical reactions. Some people call this the speed of the reaction. Alright, what a reaction rate is the change of concentration, such as molarity, parts per million, of the reactants and products, and it's going to change in a certain amount of time. That's important. So it's how much it's changing over a certain amount of time. Alright, so if you look at a reaction, you always have your reactants, that's on the left-hand side of the reaction, and your products are on the right. So you always start with your reactants and you finish with products in a forward reaction. Okay, now, if you looked at the reaction, you cannot determine the chemical change by looking at the formula. You can do this only by experiment. So lots of times you'll see data or graphs to give you information that you need to solve the rate. Right, lots of times the unit is molarity per second. All right, so in this reaction, keep it simple. We have A turning into B. So as A decreases, B is going to form. So if you looked at the graph on the right here, all right, we have 1 mole of reactants and no product yet. Because when you start a chemical reaction, you always have 100% reactants and 0 product. So as A starts to break down into B, your B is going to increase. And your A is going to decrease. My reactants is going to decrease. And now if you look, this is over a certain amount of time. So we can look at the rate between 0 to 10, 10 to 20, or we could look at the rate between 0 to 60. All right, how much it's changing over a certain amount of time. Now here we use moles if we kept the volume the same or constant. Okay, again, this is for a forward reaction only. So again, kinetics is a change of concentration over a certain amount of time. Alright, the second thing you need to know is reaction process. This is called collision theory comes into play. So, the big thing about collision theory is that you need 2 particles to collide to get a reaction. So reactants must collide to get a reaction. So, there's 2 things that matter here that you need to know to give you effective collisions. Okay, the first thing is that you need significant energy so the bonds are broken and new bonds can form. Alright, so that's basically saying, do you have enough energy to make this reaction occur? Sometimes this is referred to as the activation energy. We'll get into what activation energy is next. Okay, the second thing you need is the proper orientation or angle for the collision to occur. Alright, if it has the wrong angle or the two correct sides don't connect, alright, you're not going to get a reaction. Alright, so if you look down here on the chart on the right, alright, if the reactants are moved too slowly, they're just going to bounce off each other and head in opposite directions. So there's no reaction. Okay, the second way is if they're not lined up. Okay, proper orientation. So here, alright, my ammonia molecule is going to collide with this particle here, but obviously it's not lined up correctly. I need the blue on this side, so the red's on this side. It's not going to combine to make a new product. So again, the molecules are going to bounce off each other, and you're not going to get a reaction. And the third one here, the reactants have enough energy and they're properly aligned. They're going to collide, and you're going to get 2 new products. Okay, so when you have based on collision theory, you need 2 things. You need significant energy and the right orientation or angle to make a reaction occur. Okay. Alright, the last thing today is you need to know the factors affecting reaction rates. Okay, the big one here is temperature. If you increase temperature, you're going to increase the amount of collisions you have. So if you have more collisions, that will lead to a faster rate. So the faster the rate, the more, because you have the more collisions you have, the faster that will occur. Okay, so increased temperature makes the molecules move faster. Increased collisions, increased rate. Okay, the second thing you need to know is the concentration. Now, concentration, think about the number of particles you have. Okay, remember, collision is moles per liter, such as molarity. So the more particles I have, the higher the concentration. So if I increase concentration by putting more particles into the solution, all right, you can get more collisions. By having more collisions, you're going to lead to a faster rate. Now the opposite, if I decrease the amount of particles, I'm going to decrease the concentration. That will lead to less collisions, and less collisions will lead to a slower rate or a decrease in the reaction rate. Okay. The last one here is going to be for solids only. It's surface area. Okay, say if you have a big chunk or a powder, okay, the more surface area would be in for the powder, because the more surface area, okay, therefore your powder has more particles that can interact with the reaction. So if you have more particles that can interact, more surface area, the faster the rate can go. If you have a big chunk, right, the particles in the middle of the chunk can't interact because it's only the particles on the outside or on the surface. All right, the last two things that can affect reaction rates do not affect the amount of reactant or product that's reacting. It's something that speeds the reaction up. It's an independent substance. So it might enter the reaction, but it's going to leave the reaction at the end. So it's called a catalyst and an inhibitor. So what a catalyst does, it speeds the reaction up. It's something that's helping the reaction go faster. It's a helper. But it does not affect the amount of product. That's big. You gotta know that. Okay, so it lowers the activation energy, so makes it so you don't need as much energy to make the reaction happen. So this makes the reaction quicker. So it makes an alternative pathway or a quicker pathway. All right, an inhibitor is the opposite. It slows the reaction down. Okay, this increases the activation energy, so it requires more energy to occur, and makes the longer pathway. So catalyst speeds the reaction up, and inhibitor slows the reaction down. Okay, so those are the big factors that affect reaction rates. Let's make sure we get those down. Okay, let's answer these questions, and we'll be done for today.